Welcome back to lesson U1A3, where we discussed graphing polynomial functions from a factored form. In example number 7, we'll have to use reasoning to determine the equation of a function from given information. So here we have to write the equation for a cubic function that has the zeros at x equals -2, 3, and 2 over 5. We'll start off by listing the zeros. So zeros or x-intercepts means the same thing, or roots. So we'll write x equals -2, x equals 3, and x equals 2 over 5. Next, we will have to create the factors that we have used to find the roots of this equation. So you can think of it as if we are unsolving this equation where we got the roots from. So the -2 then will have to go back to the left side. So therefore, we're going to say that to find the root x equals -2, we must have solved the equation x plus 2 equals 0. So the -2 goes to the left side with the sign change from negative to a positive. Similar to this, for x plus 3, we'll have x take 3 to the left side, minus 3 equals 0. So that's the equation we have solved. And last but not least, x minus 2 over 5 equals 0. So we're taking 2 over 5 to the other side. Now, having to solve for x in these indicated equations suggests that x plus 2 must have been a factor. Similar to this, x minus 3 must have been a factor of this polynomial function. And x minus 2 over 5 must have also been a factor to this polynomial function. And we're almost all set. And I say almost all set because, as a matter of fact, we're ready to use the factor of x plus 2, ready to use the factor x minus 3, but we need to do a little bit of work to the last factor. The reason why is because when we write polynomial functions, we like to convert the fractions into integers. So we like to express polynomial functions with integral coefficients. In order to get rid of 5, we're going to rewrite this equation as 5x minus 2. And the way we do this is by multiplying each term by 5. So that will create 5x, and then the 5 on the other term will simplify to give minus 2. So as you can see, 5x minus 2 equals 0 actually still gives an x-intercept of 2 over 5. If you try to solve this, x equals 2, which you find by taking -2 to the other side, divided by the coefficient of 5 here. So therefore, we're going to say that we're all set with the coefficients, and all we have to do right now is put them together in an equation. So we're going to say that the polynomial function will be in the form y equals x plus 2, x minus 3, and 5x minus 2. So in order to generalize this equation, we're going to throw in a coefficient a, right? And we're going to say that a polynomial function with the indicated roots will be in the form y equals a, where a is a coefficient, a numerical coefficient, x plus 2, x minus 3, and 5x minus 2. Let's do the next question together. In example number 8, we have to determine the equation of a function with the following characteristics. So that's a function of third degree. So which means that this must be a polynomial function of third degree or a cubic function. It starts in quadrant 2 and ends in quadrant 4. So if you try to envision this, I'm going to draw the Cartesian plane here very quickly. We are going to say that this function that starts in quadrant 2 and ends in quadrant 4, it's odd degree, so it's cubic, so the end behavior will be similar to that of a linear function, which means that It's a linear function, but it's going down, which means that this has a negative leading coefficient. So a is negative, so because it looks like a line that goes down. Now, the roots are at -2, so there is one root at x equals -2, and one double root at x equals +3. So if there is a root of -2, it means that the factor where this has come from must have been from solving x plus 2 equals 0, so the factor is x plus 2. And if x equals 3, that means that you must have solved the equation x minus 3 equals 0, which means that x minus 3 is the other factor. Now, another thing that we need to take into consideration here is the order of the roots. So if it has one root at -2, it means that this must be a first order root, which makes the power of this factor 1. If it has a double root of 3, a double root of 3 is another name for the second order root, which means that the power of the factor x minus 3 must be a 2. Therefore, we're going to say that the equation of such function can be in the form y equals, I'm going to list the factors first, so x plus 2 to the power of 1. You don't have to write the power when it's 1. And then x minus 3 to the power of 2. Now, we need to point out that there must be some coefficient a in here. And we want to emphasize that the coefficient a will be a negative number. I hope this made sense, and stay tuned for more examples. Bye for now.